Hey everybody, Mr. Murray here, Mr. Murray's Mathland, and today we're taking a look at describing inequalities with interval notation. So, um, big thing to keep in mind here is that sometimes you're going to use parentheses and sometimes you're going to use brackets, the square brackets here. And the brackets are what we call inclusive. That means including whatever value you're talking about. Similar to when you use a closed circle when you sketch an inequality on a number line. And if you are using parentheses, that's what we call exclusive, so not including whatever value you might be using them around. And that's similar to when you use an open circle on a number line. So, excuse me. And so now let's just jump right into this here. And when you're new to interval notation, a tip I would say that helps you make that connection is to sketch the graph with a number line. So x is less than 2. Hopefully that shouldn't be a big deal here. Is 0, 1, 2, 3, etc. And sketching that would be all the x values that are less than 2 but not equal to 2. Right? So that would be an open circle at 2 and shaded to the left. That would be all the numbers to the left of 2. Now, when you use interval notation, you always are going to answer chronologically. So from left to right, just like you're reading here. And so where does the solution begin? This includes all the values from negative infinity, because this goes all the way to the left forever. So this goes from negative infinity up to 2, but not including it. So that's how we're going to answer it here. From negative infinity, comma, 2. From negative infinity to 2. Now 2 is an open circle, so we're not including 2. So to show that, that's when we use a parenthesis there. And negative infinity, when you're talking about infinity or negative infinity, it's not a number. You can't actually get there, so you can't actually include it. So you will always use a parenthesis around infinity or negative infinity. But there is that inequality with interval notation. And when you get fluent with these things, it's just like reading almost. You'll just interpret that from negative infinity to 2 as being this set of numbers here. So let's just see a few more examples. And when you get the hang of it, it's a piece of cake, really. So next one, x is greater than or equal to negative 1. So I'm going to sketch the graph. So you make this connection here. This is just to help me draw it here. It doesn't need to be to scale or anything. But greater than or equal to negative 1. So that's when we would use a closed circle because of the or equal to show that negative 1 is part of the solution. And greater than would be all the numbers to the right. So describing this set of numbers from left to right chronologically, right? The first thing we come to is negative 1. So this would be from negative 1 and then going on and on and on forever, so to infinity. So from negative 1 to infinity. Now negative 1 is a closed circle. We're including that value. So we would use a bracket around the negative 1. And infinity, again, you never actually get there, so that will always be a parenthesis. So, it does not have to be both sides are brackets or both sides are parentheses. You can use, you're often going to mix and match here to show this. So, yeah, this would be interpreted as negative 1 inclusive to infinity. Okay, just see a few more examples. Some more compound ones, a little more complex. Y is less than negative 4, y is greater than 1. I switch the variable to y. It doesn't really matter. It could be any variable. But this right here, just so we have a sense of where these are in relation to each other, because things have to be described chronologically. So I'm not going to fill out every number on the number line, but negative 4 is to the left of 1 on the number line. And values that are less than negative 4, so that would be not including negative 4, so an open circle, shaded to the left. Y values that are greater than 1, so open circle at 1 and shade it to the right, and then describing this with interval notation. So that means all the numbers from negative infinity to -4. Infinity, always parenthesis, and -4, not including it or excluding the value of -4. So we show that with, again, a parenthesis. And 1 all the way to infinity, even though you can't actually get there. Infinity is a concept, not a number. And so always parenthesis around infinity and parenthesis around 1 to show that open circle, not including 1. And there we go. And that could be written just like that. Sometimes you may see a union symbol put in between the two to show, this or that, but it's not necessary either. So just be flexible. Number 4, a is greater than or equal to 7, or a is less than 5. So again, I'm going to put these in the appropriate order. 5 is to the left of 7, and a is greater than or equal to 7 would be a closed circle at 7, shaded to the right. A is less than 5 would be an open circle at 5, shaded to the left, right? And so describing this from left to right here. So these would be all the numbers from negative infinity to 5. 5 is exclusive, so parenthesis there. And 7 is a closed circle, so including 7. 7 is part of the solution, so a bracket around 7. And to positive infinity. And just to show that you could do it, I'll put the union symbol this time, but that's optional. All right. So just a few more examples here, but hopefully you're getting the hang of it. And usually once you see 4 or 5 examples, you've got it down, and you're ready to move on to bigger problems where it's used. But this is just about how to interpret. And so how about when you are talking about in between two values on the number line? That's basically an and kind of statement. And these are all the values that are less than or equal to -3 and at the same time greater than or equal to -6. Both closed circles because they're both or equal to, so including both of them. And so you're talking about all those values, all the numbers in between -6 and -3. So from -6 to -3, that's what the comma always indicates. Closed circles around both, so brackets around both to show that inclusivity. And there we go. -6 to, oops, forgot my negative there. -6 to -3. And how about when you've got something like this where one might be a closed, one might be an open, closed circle at -2, open circle at 1, and all the values in between there, right? All the values less than 1 but greater than or equal to -2. No problem. We are talking about the set of numbers from -2 to 1, but inclusive, including -2, but exclusive of +1. So bracket and a parenthesis. Like I said, you will frequently use both, kind of mixing and matching. And there we go. So hopefully really getting the hang of it, and that is that. So if you have any questions, of course, always email, and as always, keep working hard.